Ladies, gentlemen, boys, girls, hawks. It's Flip Geometry with Miss Robbins and Mr. Llanos, and we're going to continue our conversation about polygons and quadrilaterals. But today, it gets deeper. Today, we talk about our favorite rectangles. Yes, ladies and gentlemen, we're talking about rectangles and everything that you can do with them. So get ready, because this is going to blow your mind. Okay, I'm joking. I'm being a bit dramatic. It's not going to blow your mind. But let's get started. So, if you notice up here, rectangles have the same five properties of parallelograms that we talked about earlier. Okay? Opposite sides are congruent in a rectangle. Opposite sides are parallel in a rectangle. Opposite sides are congruent. Again, the consecutive angles are supplementary. And the diagonals bisect each other. So everything that we talked about with parallelograms holds true for rectangles. But if you notice here at the bottom, there are two extra properties that we must talk about. The first one, as we all know, is that rectangles have four right angles. A rectangle is a quadrilateral which has four sides, so it has four angles. All of the angles are right angles, which means they are 90 degrees, and which also means that they are congruent. And each of them is 90 degrees, then they are congruent. The second one is that the diagonals are congruent. So, if you remember up here, the diagonals bisect each other, but in a regular parallelogram, in an ordinary parallelogram, not they don't always bisect. Sorry, they're not congruent. But in a rectangle, they will always be congruent. So what we have here is a rectangle. This is number one, if you don't already know, in this packet. Practice problem number one. We have a rectangle, which is a parallelogram. So we're going to go ahead and mark a bunch of things with the correct notation. Opposite sides are going to be congruent. What else do we know here? We know that the diagonals bisect each other. But now, since we know that the diagonals are congruent because this is a rectangle, that just means that each of these parts will be congruent to each other. Okay, what else do we know? It is a rectangle, so we've got congruent angles, and they are all right angles. There's a little bit more that we know, but right now this is all we really need. So let's get to work. Since we know QR, sorry, we don't know QR, we're about to find out QR. QR is this guy over here to the right, but it is congruent to this side, so this is going to be 10. Same thing goes for SR, which is congruent to the opposite side, which is 24. Now, SQ is this diagonal, and PR is going to be this diagonal here. So if you follow along, they are going to be congruent to each other, but how do we find out what they are? We can easily find out what they are if we notice that this here is a right triangle. Okay, and I'm going to highlight this part of it here. Here's the right angle, which means we can use the great Pythagorean theorem. So if I just set this up, let's go ahead and do it down here. A squared plus B squared equals C squared. We can use 10 and 24 as our A and B. 10 squared plus 24 squared equals C squared. 10 squared plus 24 squared is going to be 676 equals C squared. And if you take the square root of both of these sides, C is going to equal 26. What does that mean? That our diagonal here, SQ, is going to be 26. PR is congruent to it, so it would also be 26. And QT, since QT, this is that part, this half of it, it is half of 26, which is 13. Okay, let's move on to number 3. This one deals primarily with angles. Actually, it deals exclusively with angles. There's a lot of angles in this rectangle, but we've only got one given. But honestly, because of all the rules that you know that come with parallelograms and rectangles in particular, one is everything you need, is all you need. So again, let's go ahead and begin by marking this bad boy up. I can tell you now that the only things you're really going to need is the fact that these are right angles. Go ahead and mark those. And that the diagonals bisect each other. So again, this is going to, all four of these are going to be equal to each other in a rectangle. So let's get started. Now, let's take a look up here first at this, in this general area. If you know that this part of the angle is 27 degrees, then this other part, I'm going to go ahead and erase this highlighted part. You can tell me that if this is 27 and the entire thing is 90, then this is going to be 63 degrees. Why? Because 90 minus 27 is 63. Okay, now let's take a look at this triangle right here. Okay, what kind of triangle is it? The answer is it's an isosceles triangle. You've got two of the sides are congruent to each other. Remember, in an isosceles triangle, the opposite angles are congruent. So guess what? This bad boy is also 63. And if that's 63, this is 27. Again, this is another isosceles triangle down here. Let me go ahead and highlight it for you. This guy here is another isosceles triangle, and the angles opposite the congruent sides will be congruent. So this guy, we already said was 27. This is 27. We can keep going all the way around. 63. This one's 27. Sorry, no, it's not. That was a mistake. 63. 27. Okay, let's fill out as many of these as we can here. MJK, we know that's 90. It's a 90-degree angle. MJL, 63. JLK, JLK, 63. Is that right? Of course it is. KML, 27 degrees. And then MNL. Wait a minute, we don't have that one yet. But we've got these other two. All we've got to do is subtract 180 minus 27. Actually, minus another 27. And our final answer is 126. This angle here is 126. And now you're done. Ladies, gentlemen, boys, girls, hawks, that's it for rectangles. I would definitely try some of these other ones. Number 2, number 4, you should definitely be able to do. Try to give some of these other ones a try before you come to class. If not, you know, you can ask questions then. Okay?